Okay, here we have a path which is inclined at 15 degrees to the horizontal, so that angle there is 15 degrees, and resting on that path we've got a skip which I'm going to model as a particle, and the weight of that skip, let's just stick that in here, weight of that skip is 1500 kilograms. So it's the mass is 1500 kilograms, so the weight is 1500 G newtons. Okay, let's just put some of the other angles in here. If I put a horizontal line across there, let's put on some other forces. I've got the normal reaction, which is acting in that direction. Let's just label that as R. And we are told that the skip is being held up by a rope which is parallel to the slope, in other words, acting in this direction, and that has a magnitude of 2000 newtons. So let's just write that on. We've got 2000 newtons acting in that direction. Now, if I got rid of that 2000 newton force, the skip would slide down the slope. So I'm going to assume that friction, the frictional force, is also acting in that same direction, and I'm going to call that F. And if we just put on the other angles here, I've got a 75-degree angle there. If I just extend this line, so in the opposite direction to R, this angle must again be 15 degrees. Here I've got 75 degrees, and I'm assuming all these forces are acting at one point, but there's 15 degrees there. Now, I know here, I'm being asked to find, first of all, I'm going to work out the normal component of the contact force. In other words, I'm going to work out R. And if I consider the fact that the forces which are acting away from the slope must equal the forces acting towards the slope, that must be the case here. Forces acting away from the slope, all I've got is R. And then acting in towards the slope, I've got the component of the weight, which is acting in this direction, and that's going to be 1500 G cos 15 degrees. So if I just write 1500 G cos 15 degrees, and if I work that out, it comes out as 14,199.10 blah 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 newtons, which I can round to three significant figures to 14,200 newtons. Okay, what I'm now going to do is work out the frictional component of the contact force. In other words, I'm just going to work out the frictional force, and I'm going to use the fact that the forces which are tending to make the skip move up the slope must equal the forces which are tending to make the skip move down the slope. Now, there are two forces tending to make the skip move up the slope. There's the frictional force, which is acting up the slope, so all of that, and there's also the 2000 newtons, and those must equal the forces acting down the slope. Well, the only force which is acting down the slope is the weight, and it's the component of the weight which is acting in this direction, and that's going to be 1500 G cos 75 degrees. 1500 G cos 75 degrees. In other words, my F is just going to be 1500 G cos 75 degrees minus that 2000, and that comes out as 1804.63 blah 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 newtons, so 1800 newtons to three significant figures. The question now says that that rope is cut. In other words, this 2000 Newton force is actually just going to disappear, so that's not actually going to be there anymore. So I'm just going to get rid of this arrow completely. Let's just delete that. So we've now got the situation where the only force is acting. Let's just move friction into a better place. The frictional force must be there. The normal reaction is still there, and the weight is still there. I can see here that the normal reaction is actually going to be the same. If we look at, we've got the R acting away from the slope, we've still got 1500 G cos 15 acting towards the slope. So actually, this doesn't change. Let's just use a different pen color. This is still true. So the normal reaction is 1500 G cos 15 degrees. Okay, we're asked to work out the coefficient of friction, and we know, and we're now told that the skip is just about to slide down the slope, which means that the frictional force has now become F max. So the frictional force is what is now acting, and that frictional force is the only thing that's making the skip stay on the slope, and it must be a maximum because the skip is about to slide down the slope. And we know that the maximum frictional force is equal to mu times R. We also know that the forces tending to make the particle move up the slope are the same as the forces tending to make it move down the slope. In other words, F max, which is what's making it move up the slope, must equal the component of the weight acting down the slope. Well, that's 1500 G cos 75 degrees. Now I can put these two equal to each other. Mu r is going to equal 1500 G cos 75 degrees. And I know that r is still 1500 G cos 15 degrees. So I can now write that mu multiplied by that value of r, which is 1500 G cos 15 degrees, must equal 1500 G cos 75 degrees. And I can see that that's going to simplify pretty easily. Mu then, the coefficient of friction, is just 1500 G cos 75 divided by 1500 G cos 15 degrees. The 1500 G's disappear. I'm left with cos 75 divided by cos 15, which comes out as 0.268 to 3 significant figures.